At this point in the year, we like to look back at some vocabulary that you guys have learned about. You definitely know these words, but maybe aren't comfortable applying it in certain situations. So we like to go back, we call it our special equations mini unit, and there are 3 situations or 3 vocabulary words that we're going to be looking at. Today's is going to be, is it linear or not? So you're answering that question, yes, it's linear, or no, it's not. And we're going to be looking at the word linear in 3 different situations, from a graph, from an equation, and from a table. So first of all, the word linear, the word line is right in it. And I know you all at home know that the word linear means it makes a straight line. So that's the question we're looking for. We can't have curves, there's no circles, it's just got to be a straight line. Another thing to think about is we've been working on linear equations all year long, literally from back into the fall. So if it's something that you've never seen before, like this, it's not linear. You've been graphing these all year. We know that's a straight line. That's going to be linear. So I just gave you the answer to the first 2. This is curved. It's got a pattern we've never seen before. It's not a straight line, so this is not linear. I'd say no. This one you've graphed all year. It has a slope, a y-intercept, y equals mx plus b. Yes, this is linear. This one's a curve. This is actually called a parabola, but we haven't learned that yet. You're going to be doing those next year. There's a curve in it. It is not a straight line. No, it is not linear. And last but not least, this one, again, I've got arrows on the end. It's a straight line. I could draw it with a ruler. Yes, this is linear. So that's from a graph. I think that's probably the easiest scenario to look at from. Next is going to be from an equation. I have them up on the wall for you. And basically we're looking to see, can we change these equations around to get it into y equals mx plus b form, or Vux and Hoy, those special cases. We cannot have variables multiplied together. We can't have powers like squared or cubed. We can't have division with letters in it, with variables in it. And those are going to be what we're looking for. So for the equations, the first thing I'm going to look at and see if I can eliminate it before I even start moving it around. For this one, I see a squared. There is not a squared in y equals mx plus b. We have not seen that all year. This is not going to be linear. If I move it around, I am never going to get that into y equals mx plus b form. The next one looks like this, negative 5x plus 2y equals 0. So I don't see anything sticking out at me right away. I'm going to move this around to see if I can get the y alone and see if it's in y equals mx plus b form. So as you can recall from earlier in the year when we do this, you already know how to do it. We're going to move the x term over first, so we add 5x to both sides. And I'm left with 2y equals 5x. I don't even need to write that plus 0. And now I'm going to divide by 2. So with this one, I'm left with y equals 5 over 2x. We have definitely seen equations like that this year. This is an equation that the b is 0. I have a slope of 5 over 2. That is going to be a straight line. So yes, this is a linear equation. Next one, I've got a special case. I'm going to use this time to remind you that x, when I have x, we used Vux, that acronym. Remember, that's going to be a vertical line. It's going to be straight. I can definitely draw it with a ruler. Yes, this is linear. Next one, this one's nice and easy for you. It's already in y equals mx plus b form because my y is alone. I've got a slope of 5. I've got a b of negative 2. That's definitely linear. We've seen those all year. Next one I have here is something that I have not seen. An x times a y. That's going to eliminate it from ever being y equals mx plus b. This is not linear. Here I'm going to eliminate it right away. I have a cubed to the power of 3. We have not graphed that this year. I'm going to say no. If I graph that, it's going to have some curves in it. Next one, another special case, just like up above. This one is not Vux though. I've got a Hoy in it. This is a y in it. This is Hoy. So this is going to be a horizontal line through the y-axis at 2. That is definitely going to be a linear line. I can draw that with a ruler. Last but not least, I have division of a variable. I said in the beginning that doesn't work. We cannot have that. There's no way to move that around to make it y equals mx plus b. So this would be no. That is not linear. So those are your equations. Next, I have tables, and I'm going to start to think about slope again, another word we used a lot this year. And to be linear, looking at it from a table, we need to make sure the slope is always the same between all the points. And if you can recall, when we did slope from a table, we said how much is x increasing. So this is going up by 1, and we can kind of go down the whole way, up by 1. That's up by 1 from 2 to 3. 3 to 4 increases by 1 as well. Now I'm going to look at my y column. From 3 to 8, I increased by 5. Same from 8 to 13. Same from 13 to 18. And same from 18 to 23. Notice how I'm increasing at the same rate, or my x and y's are increasing at the same rate. So my slope here is going to be 5. I have a slope. My y-intercept, remember when x is 0, y is the y-intercept. So I could write a y equals mx plus b equation from this. My slope is consistent. Yes, this table shows a linear relationship. Next one, I'm going to go ahead, same thing again. I'm going to look at my x column and then my y column. I'm gonna, from 1 to 2, I see it's going up by 2. Excuse me, from 1 to 3, it's going up by 2. From 3 to 5, it's going up by 2. From 5 to 20, I'm going up by 15. So that's a little weird, but let's look at the y's first and see what's happening. From 7 to 11, I'm increasing by 4. From 11 to 15, I'm also increasing by 4. And from 15 to 45, I'm increasing by 30. So those look different, but remember when we're finding the slope, we're doing the change in y divided by the change in x. The change in y divided by the change in x. So those are both showing me a slope of 2. 4 divided by 2 is 2. Now the 30 and the 15 look different. Although this is a little tricky, we should know that 30 divided by 15, because the change in those 2 points is 30, the change in these 2 points is 15, but when I divide them out, I still end up with 2. Therefore, this is also showing a linear relationship. My answer would be yes, that is definitely linear. I have one more table example for you. This one's going horizontally, but that's okay. I'm going to look at the change in y over the change in x. Look at the x's first. I'm adding 1 each time for sure. So my change in the x's is definitely consistent. Here I'm subtracting 6. From 6 to 4, I subtract 2. And from 4 to 3, I subtract by 1. So if I'm looking at the change between each of these point sets, -6 divided by 1, those 2 points give me a slope of -6. -2 divided by 1, that's -2. And I don't even need to look at the other set because I already have different slopes. This would not make a straight line. So we know. Think about if the slope of your roof was changing, it would not be straight. So that's it for linear or not. Hopefully it's mostly a review and you hadn't really thought about applying it maybe in these different types of situations, but now you know you can apply that word linear. Remember the word line is right in linear, so you know that linear makes a straight line.